Some discoveries are announced loudly, others vanish quietly, not because they failed, but because they led somewhere no one was ready to explain. Thomas Townsend Brown believed he had touched one of those ideas, gravity itself. Born in 1905, Brown showed an early fascination with electricity and motion. As a young man, he began experimenting with high-voltage systems and noticed something unusual. When electricity was applied to asymmetrical capacitors, the devices appeared to move, not spin, not vibrate, they drifted. Brown believed he was observing a coupling between electricity and gravity. He called the effect Electrogravitics. Here is what can be stated clearly. Brown did build working devices. They did demonstrate thrust-like motion under certain conditions. This phenomenon, later called the Biefeld-Brown effect, is real and observable. Where interpretation diverges is why it happens. Mainstream physics explains the motion as an interaction with ionized air, an electro-hydrodynamic effect. In this view, the devices do not reduce gravity or bend space-time. They push against air. That explanation is widely accepted, and yet, it does not explain everything Brown believed he saw. Brown was not an outside tinkerer. He worked with naval laboratories, aerospace contractors, and classified research environments. He held security clearances. He moved easily through the edges of military science. And then, quietly, much of his work disappeared from public view. Not disproven, not published, just absorbed. Brown remained convinced that something deeper was at play. He believed gravity might not be a fixed force, but a dynamic one, responsive to electromagnetism under the right conditions. He never claimed to have a finished theory, only that gravity might not be as immutable as we think. Some ideas don't die, they go quiet. Brown spent much of his life working without recognition. No major academic vindication, no public breakthrough moment, just continued experimentation and continued belief that humanity had overlooked something fundamental. That kind of persistence comes at a cost. Isolation, skepticism, silence. Brown died in 1985. He left behind notebooks, prototypes, and a question that still unsettles researchers. Was the Biefeld-Brown effect only misunderstood propulsion? Or was it an early glimpse of physics not yet fully described? History reminds us that many ideas once dismissed were later reframed. Not exactly as first imagined, but not entirely wrong either. Others remain dead ends. Thomas Townsend Brown sits precisely in that unresolved space. Thomas Townsend Brown did not prove that gravity can be bent by electricity, but he did prove something else, that curiosity can persist even without validation, that some questions are worth asking even if the answers never arrive, and that the boundary between discovery and disappearance is sometimes thinner than we'd like to believe. As always, you decide.